All right, so we're back on, and I'm going to switch gears here. Going back to the Content tab, and taking a quick look back at the course calendar. Come on. Course calendar. All right, we're in week 3 already. April 18th, lecture 3 and assignment 4, assignment 3, chain drives, drive calculation. Then you're going to start working on the centrifugal fan chain drive assembly drawing. We look down here next week. There is no class next Tuesday. The college is closed. You won't be able to get into the labs. That is a SAC in-service day. Any class that starts before 4 o'clock in the afternoon is canceled. That would include this class. So there's nothing going on. Which means that I'm looking for April 27th, which would be a week from Thursday, is some kind of electronic submission progress check. And that can be uploaded into D2L. I just need to know that you're making progress. What happened in the previous assignment, some people were completely done and they uploaded the whole drawing, and that's fine. I found it really helpful to have the final electronic file, that when I was starting to check the hard copy, because I really need that hard plotted out copy to look at. There were a couple of things that I had a question about, and I could go to the electronic file and look it up and verify or not verify what was being done in there before I made some comments. And then the drawing itself, the first submission is Tuesday, May the 2nd. And after that, and then I'm going to work on assignment number 6. From that point on, it becomes even a little less drawing. You're going to get quite a bit of time to work on a drawing that you're not going to have to spend a lot of time drawing on. That was built into the schedule previously, and I'm not modifying it drastically from that. So you'll see what's going on there.
Are we still going to do advanced drafting on that Tuesday?
Yes. There will still be advanced drafting because that starts after 4 o'clock.
Yeah.
Yeah. You don't get out of that one.
Yeah.
All right. And then the assignment for assignment number 4. Here's the actual assignment. Some of this is based on previous work that I did. So it comes out of chapter 20, section 2, chain drives. The drawing assignment, this is something that I made up. It didn't come out of the textbook. I just found a fan and I found a motor, and I kind of put the two of them together as an assignment. So it would be a centrifugal fan that's driven at 2,000 RPM by a 10 horsepower electric motor. Motor speed is 1760 RPM. The shaft on the motor has a 1 3/8 inch diameter. The fan shaft has a 1 1/2 inch diameter. The center distance between the shaft and the motor is 33.5 inches. See the included handouts for dimensional data concerning the fan and the motor. You are not going to need to draw the fan and the motor. I left them in the content folder, and I'm just going to show them to you because it's a good example of what you might run across as an entry-level drafter or as a drafter. You get a catalog page and you get some dimensions, but maybe not all of them, and you have to create a drawing from that. But I'm taking that time element out, and spring term gets really hectic for everybody, instructors and particularly for students, and just trying to make your life easier. You'll appreciate that. So it's going to be a single chain operating under a smooth load condition. Calculate the number of teeth needed for the driver and the driven sprockets, and calculate the length of the chain needed. So there's the design information summarized again. So you have everything that you need. Using the charts and the tables, you're going to select the proper number and pitch of chain and the proper sprocket for the small driver and large driven sprockets. From this information, calculate the length of chain needed and include that information on the material list. Now, yes?
So, well, these mentioned like the shaft diameters.
Yeah.
Where did those come into play with the calculations?
It doesn't really.
Okay.
Just making sure that when you select a sprocket and you go to a supplier, you have enough maximum bore diameter capability to be okay for that.
Okay.
Alright.
Cool.
Now, I picked a northern blower with a model number and a fan size. We were going to make the assumption that the mounting bolts for the fan were already positioned in the floor, in a concrete floor. And due to the information from the fan that holes that were in there, I assumed that the bolts would be 9, 16, 12 UNC. That's information you need for the bill of material. The 10 horsepower electric motor is a Baldor CM3714T with a 215 TC frame. That's also design information that, as a drafter, you might be handed by a supervisor, or they're saying, we're going to install this centrifugal fan and motor and you're going to do the assembly drawing for it. And here's the information. Go make the drawing. There's a motor slide base to mount the motor on. It's assumed that they're 7, 16, 14 UNC mounting bolts embedded in the floor for the motor slide base. Once you determine the location of the motor, that's already been done for you based on where the position of the motor and the fan is going to be. There's a 3H24 UNF bolt for the motor mount bolts on the motor slide base. That information is on the dimensional data that I'll show you. I picked that it was a UNF, Unified National Fine thread. The theory is that the motor base and the motor are going to generate a fair amount of vibration. And fine threads have more threads per inch, theoretically more holding power, theoretically more ability to, once you tighten the nut down, to hold in place and not get backed out and loosened off because of the vibration. The complete fan and motor with mount drawing is provided for you to start with. Complete the assembly drawing for the installation of the fan and motor. Dimensions needed would be those necessary to position the fan and motor correctly. Indicate all necessary items needed in a bill of material. Title for the drawing is Centrifugal Fan Chain Drive Assembly. That text height is 5/32 of an inch. Drawing number for the drawing will be KIN 255-4. Text height of the drawing number is 1/4 inch. Plot the drawing at a scale of 1 inch equals 1 foot. That is a scale factor of 12. 1 inch equals 12 inches. 1 times 12, scale factor. Any size of objects on the drawing need to be multiplied by 12. The diameter of the item balloons was 5/16 of an inch on the V-belt. It will still be 5/16 of an inch when it plots out on the centrifugal fan. That means you take 5/16 decimal equivalent, 0.3125, multiply it by 12. That gives you the diameter of the item balloon when you place it on the drawing. The text for the numbers inside the item balloon is 1/8 of an inch in height. 0.125 multiplied by 12 gives you the height of the text for the item balloon. The text in the bill of material is 0.1 when it plots out. Multiply that by 12 gives you 1.2 as the text height. So forth and so on. Pretty standard stuff. You can do this from model space. You can have the drawing in model space and the item balloons in model space, or you can do all of this in layout paper space in material. What I did find out in correcting drawings is that the 2 title blocks that I had available for you on the M drive and in D2L, the C size with the bill of material was an incorrect size, so that when it plotted out, I was making comments of, doesn't look like you plotted at a correct plot scale. And I got so many of them, I began to think, there's something else going on here. I went back and checked the sizes, and lo and behold, I was the one to blame. Gee, go figure. So I deleted those and put in newer ones. If you're still using the older one, I'll compensate for that when I check the plot scale, but it would be better if you didn't use those again. If you've already got them downloaded, go back and download the newer ones that have the correct size. It was off by 1/4 of an inch. Not a huge significance. It just made the title a little bit smaller. All the rest of the sizes were correct because it got plotted at the correct plot scale. So just a word of warning on that. All right. What's the drawing going to look like? The drawing is going to end up looking like this. There's a PDF of this drawing that shows the dimensions. You're going to put the dimensions on, which means you have to have the correct dimension style with the correct text style and bold font style and all that. Otherwise, I'm dinging you by a 1/2 grade penalty for some of those non-requirement things. Most all of the bill of material has been filled in. I've left blanks for you to determine what the number of teeth are for the small and the large sprocket, and the chain type and the pitch, and then you're going to come up with. So I put in parentheses catalog number. That means that once you find the number of teeth in the sprocket, go find and put in the correct catalog number. I tricked a couple of you in the previous V-belt. I put in a bogus catalog number. And interestingly enough, some of you just left
I
it in
found
there.
those actually. I knew both were bogus because I checked them and they were
Yeah,
false.
well, you know, so I just totally took them out this time around.
Alright.
Yeah, there you go.
Give me a little-
So it's pretty much drawn for you. You're welcome. You don't have to stress out about that. Let's go back here. Go back to content. You don't need to worry about the fan shaft bearing. That was a drawing that was required in previous years to put into the drawing. The same with the electric motor. The same for centrifugal fan dimensions, motor slide base dimensions. And then here's the example PDF of the finished drawing. I'll have one up on the whiteboard for you to look at as well. And then this is the drawing that you will start with. It says KIN 255-4 drawing. You'll open that up. You'll download it. It'll be a read-only. And that's the starting point. Now, to illustrate the significance of that, why did I do all that work for you? Because I'm a really nice instructor. Okay. And the information is not readily available. So I found a catalog some years back, Series 4000 centrifugal BCI fans, model numbers and design numbers. And in that catalog was this dimensional data that students previously had to use to draw the actual drawings. And it really stymied a lot of them. Had a lot of questions answered, a lot of things that we just sort of made up because there wasn't enough dimensions. So the model fan size was 2450, and if you were drafting this, you would find all your dimensions that you need. The numbers are here, and the letter designations equate to the drawing here, and they're not all there. The configuration, these were for different configurations, so if you had different configurations, your H dimension depended on what they look like. That was the configuration up there at the top that I settled in on to use. And it got to be pretty hairy-ish. But as a drafter, this is what you'd have to work with. And a lot of times, what I would do is I would find a dimension, like dimension O. And I'd come down here and I'd find what that dimension was supposed to be. And I'd take an architectural scale and I'd measure it, the catalog page. and I'd see how far off I was from finding it. Like if I used a 1/4 inch equals a foot architectural scale, and it came out to be, you know, a little shorter than that or a little longer, I would figure out what scale to enlarge or reduce the catalog page until I got it to match that dimension. And generally, it was enough to scale that all the rest of the dimensions would match up pretty close. Then if I was missing something, like there's some angle iron in here for this frame. It's like they give you no idea what the size is supposed to be. I would have a pretty good guess as to what it was going to be just by scaling the drawing off from the catalog page. And the fans are not being made by my assembly installation drawing. I just have to get close. I just have to make a reasonable replica of it. This arc in here was different from this arc, which was different from that. I just made it look like that. So just taking a little bit of your stress out on that one. Then when I got to the motor base, it was a 215 frame, and here's my dimensions, my D dimension. So I'd go up here and find where D was, and I'd find out that that's 3/8 of an inch. Like AU is the hole size for the mounting bolts. AU is a 1/2 an inch. That's why I picked 7/16. Typically, the hole for a bolt is about a 1/16 of an inch oversized from what the bolt is. That's what gave me an idea about what the bolt was supposed to be. And that's what I went with that in my assumption. Up here, the designation for this mounting bolt is D, which was 3/8. That's where I came up with the 3/8 24 UNF. Because I just arbitrarily figured there's no information in here that tells me what it is. If I needed to know, I could call the salesperson and actually find that out. I might, need to do that. And the electric motor dimensions, pretty sketchy. Not much to go on. There's a 215T, 10 horsepower. So here's the dimensions that I did have to work with. Not much to work on. And so then I go, well, maybe they have a 3D model that I can get. Yep, sure enough, they had a drawing in there that was fairly detailed. So I downloaded it. It opened up in AutoCAD. I went in here and started taking out some of this detail. If I'd left all this detail in the drawing, a lot of it wouldn't have shown up, even with a very light line weight. It would just kind of been this black blob by the time I got done with it. So if you get in a little closer here, I took a lot of that detail out, and even some of that doesn't show up. I just made adjustments to it. So that's what you do as a drafter. You do the best you can. The motor's not being made by this drawing. I'm just showing it that it's in the assembly, and I'm making as good a representation of it as I can. There was no top view involved that I had, so I basically took the front view and sort of baked it in. This drawing of this bearing, front view and top view, came from McMaster Carr. I found a pillow block bearing that had a 1.5 inch diameter bearing to it. I downloaded the drawing, converted it into AutoCAD, took out some of the detail, stuck it in the drawing. I'm going to do everything I can to find something that's already been done. I don't have to do it all myself. And away I go, and away you go. So I'm sure there will probably be some questions along the way, but the hard part's kind of done. You're just calculating how many teeth for the sprockets, length of the chain, putting dimensions on the drawing, and following all the requirements of text, dimension style, leader style. Okay, I'm done. Now,